Consider the reaction in which lead metal is being oxidized to lead 2 ion and copper 1 ion is being reduced to copper metal. Assume the reaction is taking place at 25 degrees Celsius. A. Draw the beaker diagram and the electrochemical cell. Remember to identify the anode, the cathode, the salt bridge, the voltmeter, and the solutions. And B. Calculate the E cell, which is the cell potential, and the equilibrium constant K for the cell. So I have already done this beforehand, and I will explain it. We needed 2 compartments, which were 2 beakers, and we needed to place an electrode in each beaker. And in these beakers, we placed water as well, and we put the anode on the left side and the cathode on the right side. The anode is the lead metal, and the cathode is the copper ion in this example. And we can see the wire on the top, which is attached to a voltmeter. Electrons will always follow from the anode to the cathode, which is a rule. So the electron flow, cathode, and anode have now been identified. What we did next was add a salt bridge, which is in the middle. And we know that oxidation will occur at the anode. And at the anode, the lead metal will lose 2 electrons. The electrons will flow from the lead anode to the copper cathode. At the cathode, the copper ions will travel towards the cathode and pick up 2 electrons, allowing them to turn into copper metal. In order to calculate the cell potential, we need to look up the values and the standard reduction potential at 25 degrees Celsius, as said in the problem above. So what's important to us? It's important to remember that we're looking for the standard reduction potentials in aqueous solutions at 25 degrees Celsius. And here are what we were looking for: copper and lead. So for the anode, we'll follow the same thing that was given here, but we can notice that for the lead, it is the opposite way. So instead of being negative, it's going to be positive. And for the cathode, it's pretty much the same thing over there. So we're just going to keep the point for 3,4. In order to calculate the cell potential, all we do is simply add those 2 numbers together, and we get 0.47. In order to find the constant, well, the K value, we're going to use this formula right here. And plugging everything in, we'll come to here, then eventually here, which is where we plug in our 0.47 for our cell potential. And for the N is just the amount. So in this reaction, we had two electrons that were lost and 2 electrons that were gained. And doing this calculation, we get 15.8783783784. And we can simply round that to 15.9. And then to get rid of the log, we multiply it. Well, we add 10. And this gets rid of the log and leaves us with K equals 10 to the 16th power as our constant.